Thin layer chromatography. Sample and chamber preparation. Label your sample vial with a chemical name to avoid contamination or mistakes. Add a small amount, a few milligrams, to your vial and then add solvent to dissolve the solid. Repeat this process for all the samples. Be sure to clean any multi-use items, such as spatulas, between each sample, and remember to close any lids that you open. Get an appropriately sized beaker for the size of the TLC plate. Use a piece of filter paper to create a lining on the inside of the beaker. Cut the filter paper to the top of the beaker. If necessary, trim the filter paper to ensure it does not reach over the top of the beaker. Finally, cut a piece of saran wrap that will cover the top of the beaker. This will ensure that excess solvent doesn't evaporate during the chromatography. TLC plate preparation. When you take the plate, be sure to only handle it by the edges. Note, one side is shiny. This is typically made of glass, aluminum, or plastic, and this side is fine to touch. The other side contains the actual silica coating and should not be touched. Mark a line 1 cm from the bottom of the plate. When marking the TLC plate, only use pencil and be sure to be gentle. If you press too hard, you can scratch the surface and this will affect how the solvent interacts with the plate and can cause inconsistent results. Spotting the analyte onto the plate. First, mark on the plate which sample is going to go where. This can be done with letters, numbers, or symbols, as long as you know which sample corresponds to which spot on the plate. It's better to mark the top, as marking can damage the silica. When spotting a plate, use a capillary tube that is open on both ends. You will want to ensure that only a small volume is being transferred at any one time. You will spot with a capillary, let that spot dry, and then reapply more sample in the same spot. This is typically done 3 or more times. Repeat this process until you have spotted all of the samples for that plate. Developing the TLC plate. First, add the developing solvent to the beaker. In this case, it's a 95:5 ratio hexane to ethyl acetate. The developing solution will depend on what samples are being run. Add a little less than 1 centimeter into the beaker. You want there to be enough solvent so that the bottom of the plate is evenly covered, but not too much that where you spot it is under the level of the solvent. Place the plate into the beaker and cover with saran wrap. Make sure to keep an eye on the beaker and the solvent front. You will want to stop the TLC when the solvent edge is about 1 to 2 centimeters from the top. After you remove it from the beaker, immediately draw a line across the plate where the solvent line is. This will be needed for later RF calculations. Viewing and RF calculations. Bring your TLC plate over to the UV viewer. Make sure to bring a pencil. Press the button to power on the UV boxes, then select the wavelength on top of the UV viewer. Place your plate into the viewer and circle the spots you can see. Here is a sample RF calculation. On this TLC plate, the origin is the bottom line, which is where the sample was spotted. The solvent front, which was marked right after taking the plate out of the solvent, is the top line. As you can see, there are 2 spots, A and B. The first step in calculating RF is to measure the total distance traveled by the solvent, which in this example is 10 centimeters. Then, you'll need to measure how far each spot traveled. First, mark the center of each of the spots. Then measure from the origin to the center of that spot. In this case, A traveled 4 centimeters and B traveled 8. RF is the distance traveled by the component divided by the distance traveled by the solvent. Therefore, the RF of spot A would be 4 divided by 10, or 0.4, and the RF of B would be 8 divided by 10, or 0.8.